Under 4.5, we are going to talk about stretching graphs. And earlier on, we have seen about translating graphs, and we have identified that translating graphs is having everything to do with addition. Stretching graphs is going to have everything to do with multiplication, and it's just a matter of, again, visiting the Mayo, and I just want to place Mayo here very strategically because this is our tool. Remember, you will not find Mayo in any textbooks. This is our way of understanding transformation of curves. And as we continue to understand Mayo, which is a summary table of all transformation, we talk about TSVH, or anything you would want to say, like they should visit him, and this is Mayo. And in example 12, we are going to talk about, example 11 rather, we are supposed to, given that, and this is on page 72, given that fx is 9 minus x squared, sketch the curves with equation A. Sketch the curves with equation A. Y is equals to f 2x, and B, y is equals to 2fx. Before we can go further, it is important for you to look at this function and realize that there is a multiplication of 2. Whatever was the function of x is now being multiplied by 2, and it is inside the bracket. And there's a multiplication of 2 in the second part, which is part B, outside the bracket. So it's important to note that even as we move forward. But originally, we had the function of 9 minus x squared. And of course, we talk about y is equals to 9 minus x squared. We need now to sketch this. And 9 squared means 3. This is difference between two squares. 3 minus x, 3 plus x. And the critical values here, as you move forward, you will find that if 3 minus x is 0, then x is equals to 3. And if you take the other bracket, or minus 3. So those are the critical values of x. If we can just sketch it over here and talk about minus 3 and positive 3. Now we need to examine the nature or the shape of the curve. And if you look at the original curve, A is -1. I mean, the coefficient of the x squared is -1 and therefore less than 0. And in this case, or in such a case, then you note that our shape is an N shape. Having said that, this is just 9 because it's appearing when x is supposed to be 0. So 9 minus 0 is 9. It is this function that we need now to transform into what is expected in part A. This is to be transformed to y is equals to f 2x. Before we go further, it is important for everybody to note that the original fx, which is supposed to be fx, has been multiplied internally by 2. And all we need to do is revisit our Mayo summary table. And we talk about multiplication inside. Let us agree this is multiplication and inside. And before we go anywhere, we call this is multiplication inside. And how do we interpret multiplication inside? This one, anything to do with inside is going to be horizontal. Anything to do with outside is going to be vertical. Anything to do with addition is going to be translation. And everything to do with multiplication is going to be stretched. Now, multiplication inside happens to be horizontal stretch. This is horizontal stretch of scale factor 1/2 because our A is 2. You can see our A is 2. Horizontal stretch of scale factor 1/2, which is a half. What do we understand from the horizontal stretch? First of all, so long as it is horizontal, it means all x values. All x values. And because it is stretch, it is now not addition but multiplication. Please remember, anything to do with stretch is multiplication. Anything to do with translation is addition. So this is addition and this is multiplication. So all x values multiplied by a half. All x values times a half. Let's go back to our original graph. We have some two conspicuous, in fact 3. This is -3 conspicuous points, whereby we have specific values of x. This is -3 and this is +3 and this is x when equals to 0. So if we have to happen to multiply all x values by a half, -3 times a half becomes -1.5. So our graph now changes into -1.5. 3 times a half, it shrinks again to 1.5. And 0 here times a half remains 0. But no y value is changed. Y values are not affected. That means what? When we had, where we have the 0.09, it remains 0.9 because y has to remain and the shape is again maintained. You can see that our graph shrinks. It shrinks or it is squeezed according to the horizontal stretch of scale factor half. This one is y is equals to fx and this one is y is equals to f2x. Please note the conspicuous point which are realized. That is part A. Part B, we have to have now the graph of y is equals to 2fx. And clearly there is a multiplication by 2 but outside. Multiplication outside. You can see multiplication outside means this is multiplication outside, which is what? Multiplication outside means vertical stretch of scale factor 2. You can see our A is 2. Vertical stretch of scale factor 2. And at that point, it means what? This means all y values, because y values are the ones which are now vertical, multiplied by 2. Remember, the other one multiplied by 1/a because it was multiplication inside and the scale factor is 1/a. But now that we are having multiplication outside, the scale factor is a. That means what? The x values are not going to be affected. X values are not affected. And because we had some conspicuous value of y there, it is important to note that every value of y that was is going to be multiplied by 2. And y was 0 here, y was 0 here, y was 9 there. So our new graph appears like 0 times 2, it remains 0, x doesn't change. 0 times 2, it remains 0, x doesn't change. But 9 times 2 remains or becomes positive 18. And that point is 18. So clearly, we have been able to sketch the graphs of y is equals to f2x and y is equals to 2fx from the original value of fx is equals to 9 minus x squared. Please understand what is in Mayo and summarize every stretch or transformation or even translation according to the requirement of the Mayo table. Moving forward, we are going to have complicated curves, and again, all of them will be facilitated by the application of Mayo. All right?